Hello all, the title of my presentation is Optimizing CPU Performance for Recommendation Systems at Scale. I'll be giving the main talk on 19th of June on day 1 in the session 1A ML Systems. Now, why is recommendation systems very important? So the problem is that major web service providers offer a large catalog of products like Meta, Google, and so on. Recommendation systems inference takes into account users' history, and the goal is to make personalized suggestions to enhance the decision making among a plethora of choices available for the user. This significantly improves the user experience. We can see the growing importance by looking into the recent hardware developments like MTI accelerator, TPU version 4, Grace Hopper GPU architecture, and so on. Also, we note that this year's ISCA has 5 papers on recommendation systems. So towards the goal of improving user experience, our aim is to push for system utilization and thereby improve the cost effectiveness. Now, what exactly happens in the inference pipeline? So let's look into the model architecture where there are 4 stages. The non-embedding stages are compute bound, while the embedding stage is very memory bound. We note that the latest DLRMs are very large in memory footprint and they contain hundreds of big tables. Towards this, we consider RM2 and RM1 class of models. The following figure shows the batch latency execution breakdown, where we note that RM2 class has about 95% or more embedding contribution, while RM1 has about 60%. Now, connecting the latest DLRMs and their execution on existing CPUs, let's try to understand the research gap. So, CPUs are very abundant in the data centers and they can meet the strict SLA targets. However, the latest DLRMs bring interesting properties like they're getting bigger with more tables, they have varying degree of hotness, and they're getting fed with large parts of users' history. This brings the memory regularity challenge. Also, the MLP sizes are growing, which brings the computation demand challenge. Overall, this is bad as it increases the inference latency. So our solution is to squeeze out more performance on existing CPUs by improving the pipeline utilization. The key insights to look for in our work is the following. We do an in-depth memory regularity characterization where we discuss various hardware metrics. To solve the memory regularity problem, we propose the following optimization designs: application-aware software prefetching, application-aware hyperthreading, and the combination of both. The key results to look for in our paper is towards the batch latency and tail latency for the RM2 and RM1 models. We note significant performance improvements. So if you're interested in recommendation systems, CPU performance, and real system evaluation, you are very much welcome to attend our talk, Session 1A ML Systems on 19th of June on the first day of ISCA. See you all.